Hello, my name is Luis Felipe Pinto da Silva. My GitHub username is Ludozico, and today is 12th of March 2024. I am talking from Brazil, the city of São Leopoldo, the state of Rio Grande do Sul. Today I'm here to present my final project for the CS50 SQL, and it's called Crocodile Medical Database. We start by the design document, right? So this is a markdown document that talks about the details of my project. Let's dive directly into the code. In here we have the following tables to represent real objects from a hospital or secondary center of health. I thought that would be appropriate to create that since I'm a medical doctor in Brazil. First, we have the table patients and the doctors table, the other staff table for speech therapists, nurses, physiotherapists, and the other staff in the hospital. One limitation, it's like the administration. I did not include this administrative part, but considering this, I tried to optimize for a good balance between critical information and a lean database that could scale. We also have like the visits table, the medical records table. These two tables, I think, is the only example in my project, my schema, to have a one-to-one relationship with one another. It's important because in a hospital environment, it's really important that you don't have missing information. You cannot have something happening and don't have a medical record of it. It's obligatory, cannot be null. And at the same time, each visit should generate one medical record, right? I created some log tables below that I will talk about if this medical record needs to be edited for some reason, because sometimes we do make mistakes. But at the same time, we only want like one record for that given visit, right? We also have like the exams table, the procedures table to complement the information about like the patient care. We have the rooms table, the beds table, and the room allocations table. The room allocations table is important because in order to track where each patient is at any given time, we have to have this intermediary table. We have the medications, the prescriptions, and the prescriptions items. It follows kind of the same logic in here. We could not have just the medications and the prescriptions to have this many-to-many relationship. It's important to normalize in that sense and separate things. We also have in here some tables to register, log the modifications made in important critical tables like the medical records table, the prescriptions. Quite often you want to change a prescription, so it's important to have this automated. To do this, we'll have some triggers. This will register what was the change, create an ID for that change, store the old value, the new value in a different table for the logging of these modifications, right? We have some indexes. I tried to balance by having what I think are the most used queries, the most used searches, because at the same time you want agility, you want to have a fast database, but you don't want to create too much indexes where you would end up with this enormous amount of data. I created some views that I thought it was important as well. The contact for each specialty. If you want to contact a specific cardiologist in the cardiology department, you should have a view to access this information quickly. We have a view for the patient's data, the medical records, the results of that patient exams. Often when you are investigating a medical history of a given patient, you want to look at all of his exams at a single time, right? We have a table for room utilization. It's very important to know if the room is fully occupied, if there are any beds available. And we have another view for medications usage report. It's important to have some control over the medication usages because you don't want to be using like too much opioids, stuff like that. You need to track this information. Maybe some medications that are not currently available or are getting near to not being available. Yeah, the software will have to do some work here to interact with the database, but I really think that the database, it's in a state where it can complement the software and it can actually be a practical piece of the infrastructure of a secondary healthcare facility. This was CS50.